Alrighty. Hello. There is a little bit of echo, but I think we're going to manage. So first thing first, I would like to say a big thank you to organizers of the conference. Every year, Git Merge is a highlight of the conferences, and I'm always looking forward going here. And this year, I'm delighted to have a possibility to talk on a Git Merge. So let's give a round of applause for organizers and making that possible. Right. A little bit about myself. As said, I'm an independent consultant, and what is important for the scope of this presentation, my area of knowledge is mostly continuous delivery and automation, tooling, being system engineer or SRE or continuous delivery, DevOps. People call it differently. I also father of 1-year-old. I'm a runner and traveler, so I run to travel and travel to run. Different countries. We have a plan for today's presentation, and I'm going to talk about how Git changed what we mean by continuous integration, like my perspective on that, then branching strategies, what I think are do's and don'ts, and how do you structure repositories, as well as how you can use Git to scale your continuous delivery pipelines. To put that into context, I would like to give you a bit more background about myself. I started to use Git about 2008, 2009, and then back in 2011, I moved to Stockholm, Ericsson, to join the Git migration team, where our goal was to move project with 10 years of legacy, 1,000+ developers from IBM Rational Clear Case to Git. A lot of code, geographically distributed project, and many people actually considered it to be impossible. And we did spend quite some time doing that. So as you can see, this one is a post from Facebook where we actually finished migration. So it took 1.5 years to finalize it, but we managed to do it without downtime whatsoever. So some of the project managers didn't even notice. They came over to my desk, asked, Andrey, we heard that it's going to be a migration. Well, it's actually happened 2 weeks ago, and they didn't even notice. So we consider that as a success. It's not my personal achievement. It was a great team doing that. But during that migration, we observed multiple issues that I observed again and again when I worked as some kind of internal consultant within Ericsson, moving from department to department, helping with migrations, and then also outside of Ericsson, where I worked with various companies in Scandinavia, to name few, Volvo, Atlas Copco, Grundfos, where I was either involved directly into managing migrations or advising the teams. Actually, with some companies, we work together with GitHub engineers, helping them move not only to Git, but also to GitHub Enterprise. I also trained about 300+ people live. Most of that was done in Ericsson. But then we realized that like having me for 2 days training about 10, 20 people at a time is not efficient. We just replaced that with a video recording eventually. So otherwise, that number could be bigger. So going back to continuous integration and how Git affected that. This is my summary of the Martin Fowler article. I left few titles away from here, so I just have only some, grouped into 2 groups. One is a build automation, and another is processes. So this article was written first, I believe, in 2012, and then rewritten in 2006. So what it says is that you should automate your build to do continuous integration, which is kind of obvious. You want to have a machine that runs your build on some basis, let's say scheduled on every change. Then you want to keep it fast. You want to have it self-testing, meaning that if something fails, it fails, and you notice it straight away. What's most important that I would like to highlight here is you want to fix broken builds immediately. And I will explain why I want to highlight it. And the rest is self-explaining. So you make it easy for everyone to get latest executable, just in case if something fails, you want them to be able to troubleshoot that, or just reuse something built from the main line. Plus process. Here, actually, he says maintain a single source repository. It might be a little bit misleading. It's not exactly what Google, another company, does with monorepos. It's about versioning your dependencies, making sure that you don't have sliding dependencies, and you have all your dependencies under version control in one way or another. Right, so going back to fix broken builds immediately, this statement actually assumes that you can have a broken build, which means that back in the days, continuous integration was different from what we see today. Back in the day, it was about running daily builds, basically. Since automation didn't really allow to run it more often, or it might be other constraints, but you check the code when it hits the main line post factum, and you just discover that there is a problem, but problem is already there. And we had exactly this issue back in Ericsson. The project was distributed, so it was India, China, Russia, Croatia, States, Sweden, like basically all over the globe. Work never stops. And ClearCase had a limitation with the capacity of the view servers. I will not go into details what is that, but basically we could build only number of slots during the day or during the night. During the day we couldn't do massive builds, since that will slow down the work of developers, since they relied on performance of the view servers. So we did back in the days we did a daily build, and then I had a colleague called Christian, whose duty was to come at work about 5 a.m. so he can check daily build results and get back to Chinese and Indians, since they were about to get off their workspaces quite soon, so they can have a chance to fix if something is broken, so we can have an actual green build, and we have a test package to test. And it could be so that we would be like without green build for weeks, having no possibilities to test. So the green build was an achievement just to get everything built at the same time. So then Git actually changed the way we integrate, and I worked for some time for a company called Pragma as a CEO of Pragma Sweden, that's a branch, and also senior consultant. And I use this picture a lot to explain continuous integration, continuous delivery. And I know that the Pragma don't mind using me using the graphical art. I even asked, so it's fine. Right, so going back, what happened when you use Git or any other distributed version control system is that you have a developer who would work on his computer, and then in order to share his code, he doesn't just check in his change as it would be in a centralized version repository, version control system, so that his change immediately becomes available to the mainline and other developers. He actually needs to make an action of pushing that to the golden repository. It's some central distributed repository. It's kind of funny, but the place of truth that you agree that it will be your integration point. So we can say in our case it's a GitHub. We do push, and then we will open the pull request. Basically, you would push a branch, and then you open the pull request from the branch, which means that you can have some automated systems that can pick up your branch and build it before you actually merge it, exactly as it was shown in the previous presentation, where you would run a style bot. So you give a feedback for developer, say that, well, you might have a unit test, you might have build, you might have a static analysis, whatever is your gating activity for the merge. And that was a huge improvement back in the day when we moved from daily builds to doing the pre-tested integration, since our green build rate went from 1 in a week, or maybe 1 in 2 weeks, to more or less a couple of every day. That was huge. Back in 2011, we used Gerrit for that. Gerrit has a similar model. We didn't know that there was a GitHub Enterprise. If it were, back in 2011, we might went with GitHub Enterprise back in the days. Anyhow, it works quite nicely, but there is still an issue. And issue is that you still test on a branch. And if your Git tree looks like this, you're actually perfectly fine, right? Because when you do a merge, your master branch will be just fast-forwarded to the next commit that you already tested. It's a known state. It's a binary state. But in most cases, you have something like this. So you would test something on the branch, and then you would do a merge that will result in a merge commit. But you didn't test merge commit. You tested this one on the branch. So my point here is that testing on the branch, if master is already moved on, it's a little bit irrelevant, since you cannot be 100% sure. But again, it's about the balance. In most cases, it works just fine, because the probability of issue happening here is super low. And you might get something happening, but most probably, if you have a continuous delivery pipeline, it will catch it down the stream. Anyhow, something to keep in mind, especially when you have a conversation about feature branches. Because when people have a feature branch, they will say, but I tested my feature on my feature branch. And master is like 1 month ahead already. So all the testing they did is somewhat irrelevant, because they tested the feature in isolation, but you cannot deliver the feature itself. You deliver the product from the main line. Right, so it's up to you to decide in your organization, will you tackle this problem or not? Is it a problem for you or not? You can just say, all right, it's not a big of a risk, we just live with that. And this is what we did back in Ericsson, but I actually saw multiple departments who went on solving it in various ways. And one of the ways is a merge queue. Another way is to basically force your developers to always rebase the change before you merge. If you have a high traffic intensity in your repository, developers will hate you. Since there will be someone ahead of you all the time, and you have to rebase. If gating activity takes longer than 5 minutes, they will hate you even more. But it could be so that your quality criteria is super high, or the build is taking very long. So basically, slipping the issue to the main line is costly. So for instance, your build, for any apparent reason, takes 1.5 hours. If something slips to the main line, you will impact, well, all your development team with this issue for at least 1.5 hours before it's discovered. And then it will take some time to fix it. So it might be half of the workday. In those cases, you actually might consider doing merge queues, but still they are complex. I think the best well-known example is Zool, what people use in OpenStack project. To give you an idea how it might work is, imagine you have a GitHub, you open pull request, and then you might have a bot that listens for a certain comment, and your comment might be merge. As soon as you put that comment to your pull request, the bot will pick up your change and pull it to merge queue. And then automated system will take the commit one after another, apply on top of the main line, run your gating criteria. If it passes, it will push it to the main line. Take the next commit, apply. Take the next commit, apply. That ensures a linear history and also fixes the issue that you can have a slipping problem to the main line. But again, in most cases, it's not worth it implementing the merge queue. But if you have a lot of bored engineers who love to do something, might be a task for them. Moving on. So that was the continuous integration part, but we also needed a branching strategy. Back in 2011, this was a branching strategy, like their branching strategy. Today, I guess most of you agree that it was overcomplicated. You had two long-lived branches, master and develop. You do a lot of merges back and forth. You have hotfixes branches that you probably don't really want to have. We decided, right, that's all fine, but we want to start with something simpler. So we will go with master branch, and we will branch as necessary. And we asked ourselves as well as, like, why? Why do we want to branch? What the problem do we solve with branching? And in our case, the answer was, it's a lack of automation. So we branch because we cannot verify that the legacy still works fast enough. So that's why when we want to do a release, we would create a release branch just to make sure that there are no new changes breaking anything, and we will try to verify that. But if we would have an automated test suite that would give us a confidence that the legacy still works, then we could probably run it fast enough on every commit, which means that we don't need to be on the release branches that long, or we might or we might skip some of the feature branches. Plus, if we employ feature toggles for code branching, then we don't need to do branches in a version control. That's another choice you make. Where do you branch your code? You either branch in a version control system, or you use some other tools like or techniques as feature toggles that allows you to branch how your code executes. So you can develop the feature on the main line and then turn it on when you're ready with your testing. So we came up with a name cactus branching model, which means that we had a release branch, and then we have a master branch as a primary development branch, and then we will branch off to do releases, since we actually had in that project, we had a requirement to be able to maintain certain releases. There is even a person who came up with the same name independently from us. I don't know, he might have heard about our work. Anyhow, there is a name for that cactus branching model. And I think the trickiest part with this branching strategy is that you have to cherry pick fixes between release branch and your main line. And you need to keep track where the fixes are. Just making sure that you not only fix it on the release branch, that you also cherry pick it to the main line. Plus, you need to run the analysis, like if the fix is still applicable, because your development on the main line might move on, and you already don't have that function. So that brings a little bit of complexity here. Another common issue that I saw was when you have a project-oriented organization where you have like one project starting after another, you know what projects do, right? They're late. So you have one project which is late, you have another development project that's supposed to be started, but they share the same branch. So they need to transfer the branch between themselves. So one project needs to stop developing on the main line somehow, another one needs to take over, and then the messy thing starts. So that's another common issue to keep in mind if you are moving towards that strategy. You need to know how you're going to handle it. And if you're using projects, if it's like one continuous project, there is no such issue. And the funny thing is that the cactus model is basically exactly the same as advertised by trunk-based development. You have a trunk, you release to do fixes, and you only do a couple of commits on the release branches to reach the release candidate quality. And what we noticed back in the day is like we actually did the same thing. We worked on the trunk. We worked really hard on automating continuous integration suite, making sure that the trunk is in a good shape. Then we switched on automating stuff on the release branches. And we noticed that with every release, we had less and less commits on the release branches. Because our automation improved, we slipped less and less issues to release branches, meaning that we need to fix less things there. And branches became shorter and shorter. Eventually, they were just like a tags on the trunk, saying that we released here, but we haven't fixed anything on top of that. And yeah, so another thing that we tackled during that migration, and I discussed many times in other migrations, very common question, shall we use submodels? There is no right answer to this. That would work like in every case. I think you should ask what is the problem and you're trying to solve with submodels. In my personal opinion, the problem that submodels trying to address is a build system that sucks. Basically, your build system should be able to resolve your dependencies. If your build system cannot resolve your dependencies, you start to try to patch it in some other ways, and submodels is one of them. So imagine that you using, I don't know, Hugo for generating static websites, and then you want to have a certain theme. You can bring it as a submodel because Hugo actually don't have a means to resolving dependency from remote repository and cloning it when it generates the site. So by using the modern build systems like Cradle, Bazel, many of other systems allows you to resolve remote dependencies by picking them up from either remote repository or bring the pre-built dependencies as libraries. Git-LFS, in most cases, it's more or less the same. You have a build system that sucks, that requires you to store big binary blobs in your repository. Or it just might be inefficient if your blobs are just too big for some reason. Like, for instance, if you're, I worked with multiple projects where they would use code generators, and the source of the code generator is a binary-like XML files that you cannot merge. It's basically a binary. That's your source. You have to work with that. Then just be clever next time when you're picking a vendor for your tools. You want to have something with a mergeable source code base. Organizations, as well as your deliverable, dictate the structure of repositories quite often. And yeah, there is an ongoing debate about having multiple repositories versus monorepo. I don't want to be dogmatic, but I think we should, when we come to this question, again, we should ask what is the problem we are trying to solve, and also have an end in mind, like how do we want to have our workflow in the end. And by saying this, I mean many repositories, this is how people used to scale continuous delivery, and let me explain what I mean. So when the gray area finishes, when you have a commit that passes gating criteria, you merge it to the main line, and then you would usually run more stuff, like deploy to production-like environment, run function tests, do manual validation, maybe exploratory testing, and in the end, you're supposed to end up with a release candidate. So in this way, continuous delivery pipeline is automated definition of done, or you can also call it the way of keeping the software entropy in bay, because like you have a software entropy in your project, and continuous delivery pipeline allows you to continuously produce release candidates. And then, if you like, you can do continuous deployment, which means you deploy your release candidates continuously. But that's a completely different story, which is irrelevant right now. So that's all fine. And it's really nice if you can run your continuous delivery pipeline on every single commit, because then Git metadata contains email address of the person who committed it. So for instance, if function test failed and you run the function test on every commit, you don't need to have a trouble report going to your trouble report handling team. You can automatically send the email to that developer saying, like, you know, there is something broken in function test, and that's your commit that is involved. So it might be an environmental issue, but still, we would like you to take a look. And since you run continuous delivery pipeline on every commit, which means that it might be like only 1 or 2 hours passed since he committed this change, so he still have a fresh memory of what he did, meaning that you have a very good chances of fixing it, instead of other person, unrelated person, receiving trouble report who had to fix it. So you're decreasing the amount of trouble reports that coming to you. And there are a few ways how you can fix it. So you can either just stop and fix it altogether, but you have a downtime for development team, or you can use a really nice feature of Git called revert, and you can create an identical commit that will revert this change. So you unblock the pipeline and allow the person to fix the issue without being stressed. Both works, but both became increasingly complicated when you have a high commit inflow. So like imagine this, your car breaks down on the side of the empty road. The drivers who pass by, they will probably stop and help you. That's the same when you do continuous delivery in a team of 5. If you break something in the pipeline, it's fine, everyone goes down and fix it all together. But if you are a team of 200 working on the same repository and you block the continuous delivery pipeline, there is a high chance of an angry person arriving to scream on you. Depends on the culture of your company, but in some places at least. So how do you tackle that? There is actually some science applied on that. It's a little slow, applied to queues. So if you apply that to continuous delivery pipeline and imagine the commits as customers arriving to the queues, and time in the queue is a time in the delivery pipeline, you can easily figure out how much time is enough for you. What is your time constraint for your continuous delivery pipeline? So for instance, if you take 8 hours workday, you have 1 commit, it means that you have 8 hours to verify it, like as simple as that. You have 2, you have less time, so your continuous delivery pipeline should move faster. Also, you people do not commit, evenly. Most probably they will do a push before they go to lunch, and they do a push before they go home. Or you might have a couple of spikes during the day. Something to keep in mind. But that's what will guide you. And so far, common principle of scaling continuous delivery pipeline was either improving through output or reducing work in progress, which means that you can slice your repository into components. Like back in the 90s, it was called component-based software engineering. Now hipsters call it microservices, but essentially the same thing. You're slicing your software in pieces, and then you can have reusable pieces of software that could go to the different product lines. So it looks like this. You have components. Every component has its own repository. In the end, you might produce a binary output. It might be a Docker image. It might be a library. It might be something else that you could assembly in a system. So if you have a distributed monolith, like you think you do in microservices, but you have a distributed monolith, you can only deploy all your containers all together as a baseline. That's what you do. If you deploy independently, then those pipelines, they just keep running till production. But so far, that was a common way of scaling continuous delivery, just slicing stuff into pieces, making sure that you have less commits coming into every repository so you can have a more deep domain testing. You can even have like a multiple product pipelines, product lines looking like this. And that worked before. Now, I don't have a dogmatic opinion. I'm trying not to have dogmatic opinions about many repositories versus mono repositories, but I see that many organizations trying to embark on this journey. If you are feeling like Google and you are not, few things that you might consider are there are no tooling available out of the shelf to implement mono repository. So you will have some pain just to consider something. If you are a tools vendor, that might be a golden hour because there are many companies willing to pay for that. There are also cultural issues and also discussion about the dependencies management is quite big in this area because with the tools like Gradle, Bazel, you explicitly define your dependencies. You say that my project depends from this library, from that library, but when you have one huge repository, it's becoming very easy for a person to say, well, can I just go and link header file from over there? And you ending up with implicit dependencies that might be hard to spot. So that might deplete your architecture going forward. I mean, those are different considerations that people voice today. And I'm personally very interested to see where the whole thing is going. Probably we will understand better in a year or two, and then I hope to be back to tell you about that. That's all for today. Thanks.